Hello students, welcome to 10-minute lectures YouTube channel. Here we provide you with all the basic explanation regarding the various topics of competitive examinations. This channel will be really useful for the students of computer science branch because most of the lectures will be based on computer science. And here no lecture will exceed 10 minutes. So within 10 minutes you can get the topic cleared by yourself, and in case you have any doubt you can always comment below and we'll get back to you in a very short time. Today we are going to discuss about a compiler design, this topic compiler. So what is a compiler? Compiler is anything that converts a high level language into low level language. So before we get into the topic, we must be knowing what is high level language and what is low level language. So just a bit of explanation for that. High level language is anything that can be understood by a human being. So C, C++, Java or any such language which is used for programming is called high level language. And what is low level language? It is a binary language. So binary language means it consists of only zeros and ones. It could be understood only by machines, not by a human being. Okay, so what a compiler does is that it converts the high level language into low level language. So high level language, we have a set of code, for example, like this, just to print a hello keyword, and we have a low level language which is just a binary number. So what compiler does is that it converts this high level language into low level language. Okay, so basically this process of conversion from high level language into low level language consists of various phases. So we'll be discussing it in detail. So what are the phases? At first, let us see. First phase is the lexical analysis or lexical analyzer, which does this process of analysis. So here the tokens are created. Now what are tokens? Tokens are basic keywords. It can be identifiers. So we'll be discussing about the tokens in the next slide. So it's the basic work of lexical analyzer. It just breaks the code into tokens. Second phase is syntax analyzer. Here it creates just a simple binary tree. The structure is peculiar, that we'll be discussing later. So for the time being, you have to just understand that in lexical analyzer, the entire code is broken into tokens. Using those tokens in syntax analyzer, what it does is it creates a tree, a binary tree. Next phase is semantic analyzer. It means that it just verifies that the tree created in the second phase is correct, it is meaningful. Okay, it's just a verification process. Fourth step is intermediate code generator. It will be creating some peculiar code based on the language. So it is not the final end result, but it is an intermediate code which is generated in the fourth phase. Fifth phase is optimizing. That is, unwanted codes are filtered out and only useful codes are further proceeded with. Last phase is the code generator. Now this is the phase where our end product is something that we get in binary form. Okay, so let's go to the first phase, lexical analysis. Lexical analysis, as we have already explained, that it is a process of fetching the tokens. Now what are tokens? Tokens are identifiers, keywords, or simply some characters. Now characters may be operators. What are operators? Simply plus, minus, multiplication, division, anything. Alphanumeric may be some numbers. It can be some numbers. Keywords. Examples provided here: if, while, int, printf. Also all these are keywords. Variable or class name, these are called identifiers. Any name that we provide in our program. As far as program is concerned, we must be knowing what is a variable and how to name a class. So such things are called identifiers. So basically this all collection is known as tokens. So let's take an example. So let us consider this example: a equal to b plus c into 10. So let this be an expression or an equation which is a part of our program. So in this, if we have to speak this statement into tokens, how it would be? First one is identifier. So what are identifiers? Some variable. So here variables are a, b and c. So these three are the tokens. And after that is plus equal to an multiplication sign, asterisk. This is called operator. and this 10 is called the alphanumeric, as we have mentioned here. So just splitting up these things into these categories is the process of lexical analyzer, or this process of lexical analysis. In the second phase, what we'll be doing is that basic syntax must be correct. Okay, so for verification of that, we have a basic format called parse tree. Now there's a rule in parse tree that it is a simple binary tree where the operands must be at the leaf. Okay, so operator cannot be at the leaf, it has to be at the root position. Let's take the same example again. So a equal to b plus c into 10. So this is the statement. The parse tree for this is here given on the right side. So this equal to plus asterisk, these are the operators. It must be here at the root position. Now when you combine this whole tree, first we will be going bottom up, right? So here is c into 10. So this portion is carried out based on the operator precedence. In multiplication and plus, multiplication has the greater precedence. So first this will be executed, then this will be executed, then this whole as a whole it will be executed. So this is the basic parse tree. This parse tree generation is done in the second phase. Okay. Third one is semantic analysis. Here what we do is that we have to verify that the parse tree generated in the second phase is correct. What do you mean by that? It means that, let's take the same example again, and let's consider that this b and c, these are the integers, then only you can do arithmetic operations, right? Now what if we have declared a in a character, okay, or a string? So this entire process, though the equation is right, but it is not logical. So such cross verification that this expression really holds is verified in the semantic analysis. So if b and c are doing arithmetic operations and it is being stored in the character variable, it doesn't stay valid, right? So this verification is called semantic analysis. Next one is intermediate code generator. Now here what it does is that it just the entire code is broken in as many sample codes as possible. What do you mean by that? Let's say this is our example, a equal to b plus c into 10. Now this is the way it breaks this entire code. First what it does is it does c into 10 based on our parse tree. This c into 10 was our bottommost set, right? So c into 10, it is stored in temp, is some temporary variable or a register. Now this temp is used here, so that plus b, so this entire thing is in the temp, that plus b, that is in temp 1 position or some register or some memory location. That temp 1 content is assigned to a. So this entire one statement is split into 3 intermediate codes. So this is the task of intermediate code generator. Code optimizer, what it does is that it just removes all the unnecessary code, or it somehow reduces the resources that is being used by the computer. Now see, this was our code existing in the previous step. This is the new code existing in our code optimizer. Now what's the difference? See, here the resource is less, only one memory location has been used, temp. Here temp is used and temp 1 is used, so 2 memory locations have been used here. So this directly or indirectly just reduces the resources that is being used by the compiler. Okay, so the final step is that code generator, it just takes the code and converts it into the binary from the previous step. So once the code has been optimized, it can be directly converted into the binary. So along with that, it just allocates the resources. Resources may include registers or memory locations. That allocation is also included here. So that's it for compiler design. I am sure if you go through this lecture for once or twice, you'll be able to clear your doubts and everything. So in case of any queries, you can just send me a mail at this mail address 10minuteclasses@gmail.com, and of course you can comment also below. So if you like this video, please like it and subscribe to our channel, especially for the computer science students. Thank you. Have a nice day.